Day 3, Part 3. This is exciting stuff. This is the nitty-gritty of useful geometry. Let's push on. Okay, the converse of the Pythagorean theorem is equally true. If the sum of the squares of the lengths of any two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. Okay? If a squared plus b squared equals c squared, then triangle A, B, C is a right triangle. Now, there's more. Look at this. If you have any triangle and C is the length of the longest side, then if you square every side length, if C squared is smaller than A squared plus B squared, then you have an acute triangle. If they're equal, we already know the triangle is a right triangle. And if C squared is bigger than the sum of A squared plus B squared, then the triangle is obtuse. Can we apply this in real-life problems? Absolutely. Tell whether the measures can be the side lengths of a triangle. 5 plus 7 is bigger than 10. 5 plus 10 is bigger than 7. 7 plus 10 is bigger than 5. Yes, we can have a triangle. Yes, we have a triangle. 5 squared is 25. 7 squared is 49. 10 squared is 100. This is 74. 74 is less than 100. 100 is greater than 74. Since C squared, the big side, is bigger than the sum of the two smaller sides, so we have, not only do we have a triangle, we have an obtuse triangle. Okay, now, can we have a triangle? 5 plus 8 is smaller than 17. No triangle, so we don't even have to do any more arithmetic. I'm moving on to day 4. Recall that an isosceles triangle is a triangle with two congruent sides. Two sides that are equal. I don't care how much they look equal. If they're not marked with little hash marks, you cannot assume that they're equal. Now, the parts of an isosceles triangle include the base angles, the legs, and the vertex. It is true that every angle has a vertex, but the vertex of an isosceles triangle has a special meaning. The vertex of an isosceles triangle is a triangle is the angle that is not the same as the base angles. The base angles are always located opposite the congruent sides. So in this triangle 1, 2, 3, 1 and 2 are the base angles, and angle 3 is the vertex angle.